Hello everyone, this video is about finding the limiting reactant using stoichiometry and the balanced equation. Let's say there's an example given over here, given the number of moles of N2 and H2, and we're supposed to find the number of moles of NH3. The reason we use we need to find a limiting reactant over here is because too much information is given for the reactants. By too much information, I mean that we have the information of both N2 and H2. So it's kind of confusing which one to use for our calculation. So if I, let's say, use the 4 over here, 4 moles of N2 to find the number of moles of NH3, I might get a different answer than when I use the 9 moles of H2 to find the moles of NH3. And we cannot randomly pick one and do the calculations based on that. Because of that, we actually have to find who the limiting reagent is. And based on the limiting reactant or limiting reagent, we have to do the calculation. So limiting reagent is the compound that it's completely used. So at the end of the reaction, there will be no leftover from it. However, the excess reactant is the one that some of it will be used for this reaction, but some of it would be left over. So we always rely on the limiting reactant to find how much product is made and not the excess reactant. All right, so for finding the limiting reactant, there's two methods to use. So I'm going to show you both. Method one is a little bit longer, but it's actually a safer method. And that is to use stoichiometry, to use balanced equation, and to go from the moles of both reactants to get the moles of the product. So I'll show you what I'm explaining over here by calculating it for you. So we start with 4 moles of N2 first, and then we can use the stoichiometry, the balanced equation, and the ratios between moles of N2 and NH3, which is a 1:2 ratio. So we do for every 1 mole of N2, there is 2 moles of NH3, and that way we find that there is 8 moles of NH3 made. Now we do the same thing now again, but this time for H2. So we start from 9 moles of H2, and then we do the same mole to mole ratio thing, which is a 3:2 ratio. And we say for every 3 moles of H2, there is 2 moles of NH3. And this way we find the answer to be 6 moles of NH3. So in reality, we can only get one of these two numbers. We either get 8 moles of NH3 or 6 moles of NH3. So the one in a lower quantity, in the lower amount, is actually the amount of NH3 that we're making, which is 6 moles of NH3. So that's how much NH3 is supposed to be made using this reaction when you put in 4 moles of N2 and 9 moles of H2. And therefore, the one that gave you the lower quantity of NH3 is your limiting. So we see that that information was coming from H2. Therefore, we can say this is the limiting reactant and this is the excess reactant. So this is the limiting and the other one is the excess. However, there's a better method for finding the limiting and excess. I like the second method better, but you really have to be careful not to make a very common mistake. I'm going to explain the mistake as well. And that is by comparing the coefficients. So I'll show you how that will work. So this is my method number 2. So what I do is, just for a quick comparison, what I do is I divide the number of moles of N2 by 1 and the number of moles of H2 by 3. So I'm technically dividing them by their coefficients. So whichever gives you a smaller number is going to be your limiting. So the number here is 3, the other one is 4. So because this one is the smaller one, this will be your limiting reactant. And then the one with the 4, with the bigger number, is going to be your excess reactant. And therefore, because we know our H2 is the limiting reactant, we do the calculations using the moles of H2. But this is the part that a lot of people make a mistake with. Because we did divide the number by 3 and we got a 3 here, it doesn't mean we have to use that number. The actual number of moles of H2 is actually 9. So you have to do your stoichiometry, your calculation using 9. So we start with saying we have 9 moles of H2, which is for our limiting, and then we do the ratio thing to get to the moles of NH3. And we say for every 3 moles of H2, we have 2 moles of NH3. And that way we see that the final answer is 6 moles of NH3. And yeah, that would be it for this reaction. So using method number 2, you don't really have to do the stoichiometry to go from both reactants to the products. You can right away find the limiting reactant. And once you find a limiting reactant, you can just use the stoichiometry for that to get to the amount of products that you want. All right, so this was a very short video. I hope you enjoyed it. If you did, please make sure you like it and subscribe for watching more videos. Hope to see you next.